Have you ever wondered what is that teeny tiny number on the top? I'm here to simplify it for you. My name is Mahmoud Kiasari and welcome to my channel, Special K. So, welcome to the chapter 2 of the power part. So, in the previous chapter, we were talking about the whole power section. What is the thing that actually we call the power? What does that small number on the top of each number mean actually? About the base, about a couple of different rules, and right now we are going to move forward to another part. So right now we are going to talk about the fractional exponent and roots. And as you can see on the slides over here, I do have my first formula, which means that a divided by 1 over n. We just found out whenever we're talking about a negative number on the power side or on an exponential side, actually we are talking about reciprocal. But what would happen if we do have a fraction instead of just a whole number or a negative number? So at this point, we are talking about a root. It means that that specific number, a to the power 1 divided by n, 1 over n means that what is the actual root that I'm looking for? And by root, I mean I have to use the radical. So the thing that we know most of the time is about square root, right? For instance, if I ask you that what is 3 multiplied by 3, and you would immediately say that, okay, it is 9. And what would happen if I ask you what is the square root of 9, and you would say that 3. Square root is actually means a to the power 1 over 2, as we do have it like this. But here's the question: what would happen if I'm looking for nth root? Instead of just the second one, I'm looking for the third, for the fourth, for the fifth, and etc. Why I can do that? Because we know when we are talking about the power, exponents, and the multiplication of each number by itself, there are so many chances, or there's high chance that actually my number is going to be multiplied by itself more than twice. So at this point, let's look at the question. So I do have a 9 to the power of 1 over 2, which is we know it as a second root, or the square root, which has a very common name. So I do have that 3. This is something that I know. Another thing that we have to know would be what would happen if my fraction is not 1 over a number anymore. So at this point, what do I have? I do have an nth root of my a to the power of m. So let me give you an example, because I believe that would be very, very easier. Imagine that I do have a number, a to the power m divided by n. So at this point, would that be okay if I say that a to the power m divided by n actually is something like this? Why? Because we know m multiplied by 1 over n, or m over 1 multiplied by 1 over n is actually m over n. So at this point, I do have a number, a to the power m, and based on the law that we just learned, I can write it down like this. It means that my actual number, instead of just a itself, is a to the power of m. And also, on outside of the scope, beside the parentheses, on the top, I do have 1 over n. This is the nth root of a to the power m. So at this point, I can say I do have a radical, and this radical means the nth root of a to the power of m. So at this point, we learned that what would happen if we are dealing with a fraction as a power or exponent. If that fraction is 1 over something, nth root. If that fraction is another number over another number, we can divide it into 2 sections, and after that still we can use the first rule. So let's see some kind of example. Imagine that I do have this question: 27 to the power of 2 over 3. As I just told you, try to write it down like this. It is actually 27 to the power of 2 to the power of 3, 1 over 3. So it means that at this point, actually I'm looking for what? I'm actually looking for the root 3 of 27 to the power of 2. So I do have a 27 to the power of 2, whatever the number is, and I can find the root 3. At another point, maybe for some of you it would be a little bit challenging right now, because talk about this. 27 to the power of 2, find the root of 3 of that. I don't like it. Do we have another way? Yes, we can just follow this form. What is that? It means that I'm looking at this part because I still can do that. What does that mean? Root of 27 to the power of 2. Why? Because again, if I can write it down as 27 to the power of 2 to the power of 1 over 3, why can't I write it down as 27 to the power of 1 over 3 to the power of 2? I still can do that, right? 2 times 1 over 3 is equals 1 over 3 times 2. There's no difference. What is the root 3 of 27? Exactly. What is the number that if I multiply by itself 3 times, I do have 27? 3, 3, 3, right? So I do have this guy. So we just found out that how actually I can find the 27 to the power of 2 divided by 3. Instead of just a normal way that finding root 3 of 27 to the power of 2, I can at first find the root 3 of 27, which is 3, and multiply by 2, which is 9. Let's see another example at this point. So I do have 16 to the power 3 over 4. So what should I do at this point? Again, it would be better to find the root 4 of 16 because that's way easier. Root 4 of 16 and then move to the next part. As we know, I can write it down as 16 to the power of 1 over 3 multiplied by 4. Is that so? So it means that I can find, 1 over 4 multiplied by 3. So finding the root of 16, root 4th of 16, and then multiply, then find the power of that number, which is going to be my base, to the power of 3. So I do have a 16 root 4, which is 2 to the power of 3. It's as simple as that. So it is completely your call. It is judgment call. I can say that, okay, at this point, use A over B, or have it, for example, when I'm talking about this one, I mean, when you have A to the power of M divided by N either, you can do A to the power of 1 over N multiplied by M like this, or you can do something like this. It's completely in your hand, okay? You have to just look at the conditions. Which one is easier? Again, remember, we are trying to find a way to simplify it and make everything easier and faster. So let's move to another part, which I probably have to make another video about it, but we do have something that we call as order of operation. What does that mean? It means that if you're in some kind of equation, and in question you have different kind of operation, you have adding, subtracting, multiplication and division, and you have them side by side. There should be a rule that you have to follow, and based on that you have to find all of those operations one by one from the left to right. We do have a law and we call it as PEMDAS. So this law is just abbreviation of each of those operations. P means the parentheses. It's not considered as an operation yet. It's prioritized over other one. E as exponents or power. MD means that multiplication and division, they do have the same priority, and after that we do have addition and subtraction. So the first is parentheses, the second is exponents, third multiplication and division, fourth is adding and subtracting. Why we are using that? Look at the question right now. What do I have? So the first question is not that hard because you have 3 to the power 4 multiplied by 4. So probably maybe sometimes you would have this problem to say that, okay, why first not multiply 4 by 3 and after that find the power of 2? So obviously you cannot do that. Why? Because based on the order of operation, we know this power has privilege over the multiplication. So when power has the privilege, means that we have to find the power of that base number first. 3 to the power 2 is 9, multiplied by 4 is 36. How I can some kind of solve it wrong, find the 3 times 4, consider it as 12, and find the power of 2, and after that 144, which is very rare, but still you're trying to neglect and cancel any kind of possibility that we can make a problem, especially in an exam. So let's see another question, and this question is better. So at this time I do have 3 multiplied by 4 parentheses to the power of 2. So what does that supposed to mean? It means that at this point I do have parentheses, and after that I do have multiplication. So what would happen at this point? You can see that since I do have parentheses, anything inside of that should be resolved, and then I have to move on. So I do have a parentheses. I do have 3 multiplied by 4, which is 12. Right now it would be 12 to the power of 2. For some of you that actually so curious about that one, I believe you can tell me that what is another way that I can do that. I believe you did it right. If you remember from one of our rules we had, if we do have a multiplied by b to the power of m, actually we can write it like this: a to the power of m multiplied by b to the power of m. So what is that supposed to mean? I do have 3 times 4 to the power of 2, all in parentheses. I can write it down as 3 to the power of 4, so 3 to the power of 2, and 4 to the power of 2. Find that one, and you still have to have 144. So let's move on and talk about a very, very interesting topic that actually you're going to see a lot in your advanced courses, and we do have it as scientific notation. If you remember from the beginning of this work, I told you that the reason that we are using power, that sometimes we are dealing with so many big numbers or so small numbers. So on that point, we do have 2 choices. The first one, which is the hard one, means that I have to write down a specific number, and all of these are zeros beside of that. Imagine you do have 32 billion, and after that you have to write 32 multiplied by what, and all of those zeros, if you don't want to use any prefixes, by the way. But I do have another way that is easier. It means that somehow I can use the power. What does that mean? It means that imagine you do have a number like this, 7,200,000, and after that I would ask you to write down this number based on the rule that we know it as scientific notation. So scientific notation follows an easy path. It would say that whatever number that you have, I can write it down based on 2 things. One, which is considered as my base or my some kind of a number, multiplied by 10 to the power of n. What is n? N actually is the number of zeros beside a. But here's the question: Can a be anything? So obviously not. A cannot be anything that you have in your mind. So what do we have at this point? I do have a number, and that number should follow a rule. And what is that rule? That rule says that that specific number, we don't care how the whole big number is. Is it big? Is it small? We don't care about that. That specific number, which we know as a, should be something between 1 to 10. And after that, you just multiply it by 10 to the power of whatever zeros you need. So let's see an example, because I believe that would resolve anything that you have questions in your mind. I do have 7,200,000, and I would ask you to write it down as scientific notation. We know that this guy should be written as 2 parts. The first part is the power of 10. This other part is going to be a number between 1 and 10. So when we are thinking about a number between 1 and 10, you are thinking about 7.2. Why I'm thinking about the 7.2? Remember that if I'm going to use the power of 10, 10 to the power of any number means that either I do have more zeros that I have to move the decimals to the right or move the decimals to the left. I would give you a small example in order to understand what is going on. When I do have 200, I can write it down as 2 multiplied by 10 to the power 2. As you can see over here, this is a very, very simple scientific notation. I do have my a, and after that I do have 2 zeros. Why 2 zeros? Because if you consider this is your number, something between 1 and 10, how many zeros you have to put beside the 2 in order to make sure that this multiplication is going to go same value as the one that you had in your question? Obviously 2, right? Imagine instead of this, I do have 0.02. And if I ask you to write it down as scientific notation, you have to do this. Why negative number? If you remember, I told you when you do have a negative power, that seems like reciprocal. 10 to the power of negative 2 actually was 10 to the power of 2 to the power of negative 1. We know rule, right? 10 to the power of a times b. It actually can be written as something like this. So this one is 1 over 100. Whenever you see that its number, the whole number by the way, is smaller than 1, you have to know that in your scientific notation you are going to see negative numbers for your 10. And when you see that your number is bigger than 1, actually in your scientific notation you are going to see a power of positive number. So let's just look at the question again. 7,200,000. I would like to write it down as a scientific notation. Again, I have to deal with one number and after that the power. My number is 7.2 because look at this one. Either I can move the decimals to the left so much to reach 0.72, or I can move it not that much to the left to reach 72. So I'm not going to use any of that. 7.2 is my number. It's between 1 and 10. What about the power? How many zeros I have to put beside my 2, or how many steps I have to move my decimal point to the right to make sure this number, this multiplication is going to give me the same value. That's right. So I have to move it 6 zeros or 6 decimal points. What does that mean? Look at this number. So I do have this one, 1 step, 2 step, 3 step, 5 step, and 6 step. It means that by 10 to the power of 6, actually I'm trying to do what? I'm trying to make my 7.2 to 7,200,000. Let's look at another number. I do have 0.00056, and after that I would ask you to convert it to what? To convert it to a scientific notation. Again, 5.6 is the first number that reached to your mind, and after that you have to see how many decimal points I have to move that specific dot to the left in order to have the number which is 0.00056. Exactly, that is 4 times to the left. Since 4 times is to the left, I have to use -4. When I do have 6 times to the right, I have to use the positive number. So I do have it as it is. Simple as that. Again, when you have a scientific notation, the only thing that you have to do is 2 things. First one, find a number between 1 and 10 that could be resolved or that could be fit inside your question. Second one, find how many decimal points you have to move either to right or to left in order to reach to your final number. So again, the reason that you're using the scientific notation is that obviously we are dealing with big numbers, and after that they are going to be easy to compare. Imagine that you have a very big number and you are trying to just compare it to another big number. So the only thing that you have to do, convert it to scientific notation. Either their A or base number is bigger than another one, or if they're the same, their power is going to be bigger or smaller than another one. So you can just compare it very easily. So let's look at the linear and exponential growth. So this is something advanced, and I have to say it's sometimes related to linear algebra, but I thought it would be better to at least know and have some ideas that how big actually the power is. Imagine that I do have 2 conditions. The first condition is that I do have a formula, and my formula followed this: start point plus k times the number of steps. What is that k? K means that each step is going to add how much to your some kind of number. But some kind of very simple example means that saving 100 each month, right? So you would start from $0, and after that you have 100, you have 200, you have 300. Nothing is strange. One is going to be added up to another one. We don't have anything strange. By the way, why use the multiplication? As you can see, 100 2 times, 100 3 times. So we know when we do have the same number, we are going to add it up by itself. We are going to use the multiplication. On another hand, we do have another scenario. We do have this formula: start multiplied by r to the power of steps. And r again is each steps. Imagine that you have the bacteria and that one is doubling. It means that at each generation it is doubling. It would start from 1, 2, 4, 8, 16, so on and so forth. It's not just by adding a number by another number. It's talking about multiplication. 1 times 2 to the power of 0. 1 times 2 to the power 1. 1 times 2 to the power 2, and so on and so forth. So this is something that we call it as exponential growth. And another one that we just learned was something that we call as linear growth. Why? Because if you draw that one into this rectangular system, again, we will talk about it in the linear algebra, you don't have to know it. The first one is going to increase like this, but the second one is going to increase like this. At the beginning of the point, they're so the same. But after some point, after some time, the exponential value is going to be very bigger than your linear value. So you can see an example in a table. Imagine that you're starting with $100 and you're going to add it $220 each step. At the beginning of the point, which is the step number 0, so you don't have any having any adding up, so you have 100. After that, 120, 140, 20 at a time, plus 20. But at another point, we are talking about the $100, which is going to grow by 1.2. It means that at some point, you're going to add 20. After that, you're going to add 24. And after that, you're going to do something. You see that this adding is not going to be something constant. It's going to follow its exponential value. Again, I'm not expecting you guys to understand it completely right now. We are going to have a very, very advanced course about the linear algebra, and I'm going to talk about everything there, so don't worry. So far, we learned so many things about the power, how actually we can do the multiplication, how we can some kind of separate them, how do we have the division rule, about the multiplication rule, what would happen if we do have the scenario that I do have parentheses and exponents at the same time. We are going to use the PEMDAS, and after that, we did a lot of things. By the way, it's PEMDAS. It's sometimes going to be confusing. PEMDAS is just like the proportional, is not like the proportional. It's a parentheses, exponential, multiplication, and division at the same rank, and after that, adding and subtracting. Again, I'm going to make a video about it, don't worry. So right now, let's look at some common mistake, which I've seen thousands of times among the students, that they had this one, and you don't know how frustrating could it be. You do have a question, you answer everything, but after that, this problem comes up, and boom, everything is going to be collapsed. So imagine that you do have a scenario, 2 to the power 3 plus 2 to the power 3. And you would say that, they do have same base. And also, I know something about the power. Since same base, I can add up the power, right? No. Why? Because when we are talking about the power, we are talking about multiplication. We are not talking about adding. 2 to the power 3 plus 2 to the power 3 is in completely another scenario. Means that 8 plus 8, which is 16. If you find the 2 to the power 6, which is going to be 64, there's a huge difference between those two. So please be careful. If I do have 2 to the power m plus n, at some point I would say that, okay, it's easier to write it as 2 to the power m plus 2 to the power n. Wrong. Be careful. When we do have this rule, we are talking about what? 2 to the power m multiplied by 2 to the power of n. So again, we have the rule like this. Please be careful. And about the sign trap. So remember, you have to follow the order of operation. PEMDAS. Whenever you have parentheses, you have to honor it. First of all, do whatever it is inside the parentheses, and after that, do the power. If that guy is not there, you can do what? You can do your power, then come back. So imagine that I do have a question, negative 2 to the power of 4. You see that it's something like the second part, something like this, and it is so common to confuse these two together. So negative 2 to the power of 4 means that, okay, I do have negative 2. I can multiply 4 times by itself. So it's going to be 16, right? No. Why? Because based on the rule that we just learned about the PEMDAS, first of all, we have to honor the power, which is 2 to the power 4. Then we have to honor the multiplication. Negative of each number means that negative 1 multiplied by that specific number. So I do have 2 to the power 4, whatever the number is, and after that I do have negative 16. On another hand, I do have negative 2 parentheses to the power 4. Based on the PEMDAS, I do have negative 2 parentheses, and right now I can do it because right now negative 2 is considered as one term for me. Negative 2, negative 2, negative 2, negative 2. Now I do have 16. Be careful about this number. It is so common to have this one in so many cases. So this is some kind of the common tip that we have. Again, when you see some simple numbers like this, trying not to just multiply them together, and please be careful because it is so common, and that's it. So let's move to some kind of mixed questions. So what would happen if I'm a cook, and after that in my receipt I'm going to some kind of do some mix and matching. It means that rather than just using one rule, I'm going to use different rules. How am I going to do that? Simple, like this. I can twist it so easily. Imagine that I do have 5 to the power of 2 to the power of 3 and divided by 5 to the power of 4. what would you do? So the first thing that as a student, as a normal student that you would see was, oh my God, we're panicking, right? Oh my God, we do have a parentheses, we do have a power, we have division. Okay, what the hell is going on? So no, try to stay calm and relax and think about the simplification. Remember, whenever you have fraction, whenever you have parentheses, try to get rid of them. You don't like them. You like the piece. You like the simplified version of each question. So when I do have 5 to the power 2 to the power 3, the first thing that would come to my mind is that, okay, the parentheses seems not friendly. I'm going to get rid of that. How? We know a rule. A to the power b, or maybe we use the m, a to the power m to the power n is actually can be considered as a to the power of m multiplied by n, right? So I do have a parenthesis over here. 2 multiplied by 3. It would be 5 to the power of 6. So instead of just having this guy, I do have 5 to the power of 6. That would be easy. 5 to the power of 6 divided by 5 to the power of 4. We know if we do have the same base, we can subtract those powers or those exponents from each other. 5 to the power 6 divided by 5 to the power 4, 5 to the power 6 subtracted by 4, and after that I do have 5 to the power 2 or 25. Simple. So let's look at another example. At this point, I do have 2 to the power 5 times 2 to the power negative 3. We know that one, right? Same base, different power. Add them up. 2 to the power 5 subtracted by 3. Again, some of you would say that, okay, it seems like division. It actually is. Why? Because if you remember, I told you, whenever you have a negative number, actually you're dealing with a reciprocal. So at this point, actually you do have this one to the power of negative 1, which is 1 over 2 to the power 3. Again, if you know about the multiplication and division, which we already have a video over that, if I do this one, if I do this, and I would like to convert something related to that, it would be 2 to the power 5 multiplied by 1 to the power 3. It's like division, right? 2 to the power 5 divided by 2 to the power 3. 5 subtracted by 3 is 2. I just solved this question in 2 simple ways. See? Let's look at another example. Ooh, that's a big one. I do have 3x to the power 2, y to the power negative 1, everything to the power 2. So this kind of question is so common in linear algebra, but have it in your mind. Not all of your terms are going to be numbers. Sometimes your terms are going to be unknowns. It means that at this point, as the guy that's going to design the question, I'm not sure what is the value of x. I'm just saying that this is something that maybe in the future I would decide about that. But right now, it's just a term. So it means that unknown is going to be x, y, z, or whatever alphabet that you're going to use. Okay, so at this point, I do have something like this, and to the power of 2, I'm looking for an answer. If you remember about a rule that we had ab to the power of m, actually I can write it as something like this. Here's another question. Can I expand this rule? It means that, would that be okay if I say that abc to the power of m, I can write it a, b, c, and yes, you can do that. Simple as that. You can, the good thing about the power and multiplication is that you can expand it. About the division and other kind of thing, it would be a little bit challenging, but right now we can expand it. So it means that I can separate this one into 3 different terms. 3, x to the power 2, y to the power negative 1. Everything to the power of 2. Remember, PEMDAS. I do have the parentheses, I have to honor that, keep all of those values, and after that, you look at the power of 2. 3 to the power of 2, which is 9. X to the power 2. To the power 2, we know it is going to be 2 multiplied by 2, and after that, y to the power negative 1 by to the power of 2 is going to be y to the power negative 2. So just keep those numbers to each other, and after that, either you can write it down like this, you can write it down like this, which is going to be this one. It doesn't matter. As long as you have this number, if I was your teacher, if I was your instructor, I would say that you get the full mark because you completely understand the concept of power. Let's look at the last question. 81 to the power of 3 divided by 4. Okay, this question seems a little bit challenging right now, but again, it is something that we did before. If you remember, I told you 81 to the power of 3 over 4 can be written as 81 to the power of 1 over 4 everything to the power of 3. So what is the number that is going to be multiplied by itself? 4 times you have 81, 3. So we do have a 3. 3 to the power of 3 is going to be 27. So about the some kind of numbers between 1 and 100, I would highly recommend you to know about the square root, about the root 3, or about the root 4 if you can. This is something that you can memorize it, or when you have free time, you can just think about it, or maybe write down over the cheat sheet, I don't know. But these are the things that actually are going to be so useful for you. So let's work on real world problems with how actually we are going to some kind of have those powers. Yes, we are going to deal with big numbers, but is there any way that I can use it actually? Yes. If you remember for the power part, when I was trying to show you the difference between the exponential and the linear, I had an example which was about the bacteria. So it means that if I do have the bacteria, and if I do have 500 bacteria, and I know by each some kind of, there are going to be a double every hour, and if I ask you after 8 hours how many bacteria you have, you can just simply write it down as a base number, 500 multiplied by 2 to the power of n. So how many hours? N hours. So I do have it as 8 hours. So 500 times 2 to the power 8, and simple. So another thing is that about the interest. It means that at some point you have the compound interest, and you would like to see that after some times how much is going to be your interest. So you can use this formula, or you add the pixel scale, or you just name it. So this is another practice for you. Again, you do have the answer. You just try to cover up your answer, think about it, pause the video, some kind of do all of those answers. If you would like me, I mean, you can just have your answers in the comment, and after that, if you want, we can discuss about it. But again, it's not that kind of hard thing for you. So let's just end this part with a cheat sheet. So again, we start with from the very, very basic thing about the powers. What are they, how we are going to use that, and a couple of different laws. The first law that we, or rule that we remember, is about the product law. The product rule. It means that if I do have a to the power m times a to the power n, actually I can add the powers. If I do have the quotient rule, means that a to the power m divided by a to the power n, I can subtract them. If I do have the power to a power, and I do have a to the power m, everything to the power n, I can multiply those powers together. Another rule that we some kind of learned, but we're about distribution laws. It means that ab to the power of n actually can be written as a to the power n multiplied by b to the power n. If I do have a divided by b to the power n, again the same scenario, I have to keep the power for both of them. And we had some kind of exceptions. It means that a to the power of 1 is equals to 1. A to the power of 0, any number to the power of 0 is also 1. And remember, 0 to the power of 0 is going to be undefined. And after that, we were talking a little bit about the negative exponents. Whenever you see a negative, you know you're dealing with reciprocal. And we were talking about the factor, we were talking about the radicals, about the fractional exponents, and any other kind of things. So thank you very much for being here with me again, and you did a very, very fantastic job. We were talking about the very, very confusing topic, especially about the power, especially when you're talking about adding them or multiply them or divide them. So again, try to pause the video, try to re-watch it again. If you see that you have any problem, just ask me in the comment below. And after that, we can just have the separate video to talk about more and more examples. And if you don't have any problem with that, I would be so happy if you just like and comment, and if you want to share it with your friends, that would be really, really helpful for me. Have yourself a great day, night, whatever. See you around.